How you guys doing? Welcome back, everybody. For this video, I'll be discussing the Grignard reactions with carbonyl functional groups, and the Grignard reaction is basically going to reduce the carbonyl groups to form alcohols, and you're going to form a variety of different types of alcohols: tertiary, secondary, even primary alcohols. So let's get started. The four, or actually the three carbonyl groups that I'll be talking about include the ketone, the aldehyde, and the ester. I was going to talk about the carboxylic acid, and I will do it briefly, but essentially the Grignard reaction with a carboxylic acid is going to result in an acid-base type of reaction, and you will yield the reactant. So let's get started with the ketone. So if we have a ketone, right? R groups basically being any type of alkyl group. So it could be aromatic ring, a phenyl group, or alkyl, propyl, butyl, a pentyl type of group. Anything could be the R, but it's an alkyl group, and that's going to react with RMGBr. Okay, and this Br could be even or Cl. Okay, it could be bromine or chlorine, and you have H2O, H plus, comma workup, and this H2O H plus workup is going to neutralize the negative oxygen you have to form the alcohol. It just neutralize the negative on the oxygen, and this will give you a tertiary alcohol. And this is very important in synthesis type of reactions if you want to form a tertiary alcohol from a ketone. So R1 referring to this one, and R and your alcohol. Okay, and don't get this confused. It's not a covalent bond. This is an ionic bond. This R group essentially has a negative charge, and this MgBr essentially has a positive charge. And this is showing the connection between the two, the electric force between them that's holding them together. Excuse me. And the mechanism essentially for this is pretty simple. You have your R group, this ketone. Very simple. You have R1 MgBr. This will add into the carbon of the carbonyl group. Okay, we showed the arrow usually coming from this supposedly covalent bond, but it's not. Don't get it mistaken. It looks like covalent bond, but it's not. So it comes from here to here, the arrow, and this double bond ends up becoming a single bond. The pair of electrons go on the oxygen, which results in this R1 R, right? And then you have the workup at the end, the H2O, comma H plus workup, right? All it is, that workup, just to neutralize that negative charge, and that's it. And then your product will be this tertiary alcohol. And there you have it. Now the next carbonyl functional group I'll be talking about is the aldehyde. Follows the same thing. I'm not going to show the mechanism because it follows the exact same mechanism. You have an R and an aldehyde, and an H for the aldehyde, reacts with the R1 MgBr, or it could be Cl. Excuse me. You have the H2O H plus workup, right? Is going to give you a secondary alcohol. So R prime, R with the subscript 1, and OH. Okay. See, yeah, so it's gonna be, you cannot really, you know how usually when we determine if a carbon is tertiary or a secondary or primary, we look at the carbon. So say for example we want to determine if this carbon is secondary, tertiary, or primary. We look at this and we say, well, it's connected to one carbon here and another carbon here, so it's secondary carbon. However, in this case, we cannot do that for this alcohol. What we do is, in order to determine if it's secondary or tertiary, you have to look at the carbon attached to the oxygen, and if that carbon is attached to two other carbons, then it's considered secondary. And if the carbon that's attached to the oxygen of the alcohol is attached to three other carbons, like this one we have here, right? This carbon is attached to the oxygen of the alcohol, and this carbon is attached to three other carbons, so it's going to be a tertiary alcohol. Okay, so in order to determine if your alcohol is primary, secondary, or tertiary, you have to look at the carbon attached to the oxygen, and you base if it's primary, secondary, tertiary on that carbon to see what is that carbon attached to. So yeah, so you form the secondary alcohol. Put a secondary, and this is a tertiary alcohol. And the carboxylic acid, essentially, I'm not even gonna talk about that much, because you're gonna form the reactant, which is that carboxylic acid you started off with, is gonna be in the product. And so basically, I usually put no reaction. And the other one I was going to talk about is the ester. So if you have R, the R right here, reacts with a Grignard reagent, you have your R1MgBr or Cl, right? This will react. You need your H2O, H plus workup. This will give you two alcohols, a tertiary alcohol and whatever other type of alcohol you have based on this R group. So R OH, so you get two. Okay, so that's what you form when you have an ester reacting with a Grignard reagent. Now I'll show you guys the mechanism for this one, because it does not follow the typical mechanism like I have drawn here for the ketone or for the aldehyde. So the mechanism for this is a little bit longer, but it's pretty easy, it's pretty straightforward. So let's get to it. Okay, so let's get this out of the way. So the mechanism for this ester will be, if you have this ester here, and it's reacting with this Grignard reagent, so R1MgBr. Okay, the first step is pretty easy. It's the same like for the ketone. The R group, R1, will add into the carbon of the carbonyl. This will pop off to go on the oxygen. So you have R O negative, O R R1. So that's what you have to begin with. Now what happens is that you reform the carbonyl while kicking out this OR group. Okay, so you'll form the carbonyl again, and you'll kick this off. Okay, so what your result is from this step is you have a ketone plus O minus R. But you cannot stop right there. You have to continue going. You add another equivalent of the Grignard reagent. Okay, again into the carbon of the carbonyl So it adds again. You reform that O negative. So what you end up with from this step is R O negative R1 and R1. So you're not going to reform the carbonyl. What's going to happen is the final step in this mechanism is going to be the H2O, H plus, work up. Okay? What happens is that now both this piece that was kicked off from the original ester and this soon to be tertiary alcohol will be neutralized. They will neutralize their negative charges by this H2H plus workup. So this you could draw like this. This will attack to get some of the H. This also. And you'll end up with R1 alcohol, right, plus OH R. And there you have it. Basically, you form a tertiary alcohol, right? Because the carbon attached to the oxygen, right? This carbon is attached to 1, 2, 3 different types of alkyl groups, and so that tells you that it's tertiary. So the alcohol is tertiary. So tertiary, and this is, since the R group, it could be essentially anything. This carbon can be attached to 3 other things, and so there you have it. This will be, in this case, we'll just say it's primary, assuming that this is just a carbon with 3 H's hanging off. So that's it, and it's just a little quick recap. If you have a ketone, the Grignard reagent is going to add once into it to give you a tertiary alcohol. We'll go right, tertiary. If you have, and this is a little mechanism for the ketone, right here. Grignard reagent adds into here. You form the O negative, gets neutralized by the workup, and you form the tertiary alcohol. Aldehyde essentially follows the same mechanism, but instead you form a secondary alcohol. The ester, you add the R group twice into the carbon of the carbonyl, and essentially this little piece right here, this OR kind of group, will kick off. And the mechanism is shown right here. A little bit messy, so let's kind of cover this piece. Okay, what happens first? R adds into the carbon of the carbonyl. This kicks off to give you the O negative, which is shown right here. The OR group is kicked off, and you form the carbonyl again. You're left with something like as shown right here, and here. The O minus with the R and the ketone. The Grignard reagent, the R1 adds again, forms the O negative with 3 R's now, and at the end it gets neutralized. Both this piece right here and this piece right here gets neutralized to give you your final product of this. Just tertiary alcohol and this primary alcohol. And again, this could be primary, secondary, tertiary, depends on what this R group is. Alright, I hope you guys enjoyed. Hope you guys learned something. Again, any questions, any requests, feel free to leave a comment. And I hope you guys enjoyed. Thank you for listening.